Hello friends, this video is brought to you by www.moateaching.com.
Let us start with this interesting chapter on rational numbers. Firstly, we will revise whole numbers, integers, and rational numbers. Then we shall study the properties of each of these numbers. Then we shall learn to represent them on number line. We start by revising numbers. Let us start with natural numbers. We start by revising numbers. We start by revising numbers. Let us start with natural numbers. All the numbers starting from 1, 2, 3 and so on are natural numbers. Next we have whole numbers. Numbers starting from 0, 1, 2, 3 and so on are whole numbers. Integers include 0, +1 and -1, +2 and -2, +3 and -3 and so on. Next we have rational numbers, which can be written in the form P by Q, where P and Q are integers but Q cannot be 0. For example, -2 by 3 is a rational number, 6 by 7 is a rational number, and so on. Also, all the integers are rational numbers, since we can write 2 as 2 by 1 or -3 as -3 by 1. So, we can say that all integers are rational numbers. Let us start with the closure property of numbers. According to this property, if we add two whole numbers and the result is also a whole number, then we can say that the whole numbers are closed under addition. So let us check it. Suppose we add 0 plus 5 will give us 5, which is also a whole number. 4 plus 7 will give us 11, which is again a whole number. So we can say that whole numbers are closed under addition. Now let us check for subtraction. If we do 0 minus 5, we get minus 5, which is not a whole number. Minus 5 is actually a integer. If we do 7 minus 4, we get 3, which is a whole number. But since we can find at least one case which does not satisfy the condition, hence we can say that whole numbers are not closed under subtraction. Now let us check for multiplication. If we multiply 3 with 7, we get 21, which is also a whole number. Let us check for 0 into 8 is 0, which is also a whole number. So we say that whole numbers are closed under multiplication. Now let us check for division. If we take two whole numbers 5 and 8 and divide 5 with 8, we get 5 by 8, which is a rational number and it is not a whole number. So we can say that whole numbers are not closed under division. Let us now check closure property for integers. We start with addition. Let us add any two integers, say minus 6 plus 5 gives us minus 1, which is an integer. If we take 0 plus minus 2, it gives us minus 2, which is again an integer. So we can say that integers are closed under addition. Let us check for subtraction. We know that 7 minus 5 will give us 2, and 2 is an integer. Minus 6 minus 8 will give us minus 14, which is also an integer. So we can say that integers are closed under subtraction. Let us now check for multiplication. If we multiply 5 with 8, we get 40, which is an integer. Let us multiply minus 2 with 0. We get 0, which is an integer. If we multiply minus 2 with minus 4, we get plus 8, which is again an integer. That means that integers are closed under multiplication. Let us now check for division. If we divide 5 with 8, we get 5 by 8, which is not an integer. 5 by 8 is a rational number, so we can say integers are not closed under division. Let us check closure property for rational numbers. Let us start with addition. We take two rational numbers 3 by 8 plus minus 5 by 7 and add them. It gives us minus 19 by 56. We can say that rational numbers are closed under addition. Let us check for subtraction. Minus 5 by 7 minus 2 by 3 gives us minus 29 by 21, which is again a rational number. Hence we can say that rational numbers are closed under subtraction. Now let us check for multiplication. Minus 2 by 3 multiply by 4 by 5 gives us minus 8 by 15, which is again a rational number. Let us check for another example. Say 3 by 7 multiply by 0, which is equal to 0, which is again a rational number. Hence we can say that rational numbers are closed under multiplication. Now let us check for division. Let us take minus 5 by 3 divide by 2 by 5. Let us solve this. Let us try to understand commutative property. Say we take two numbers 5 and 2. Both are whole numbers. Now, firstly we can see that 5 plus 2 is equal to 2 plus 5 equal to 7. So we can say that addition is commutative. Next, let us try 5 minus 2 is equal to 3, but 2 minus 5 is equal to minus 3. This implies that 5 minus 2 is not equal to 2 minus 5. Hence we can say subtraction is not commutative. Let us try multiplication. We know that 5 multiplied by 2 is 10 and 2 into 5 is also 10. This implies that 5 into 2 is equal to 2 into 5. Hence we can say multiplication is commutative. Let us check for division. 5 divided by 2 will give us 5 by 2 and 2 divided by 5 will give us 2 by 5. Clearly, 5 divided by 2 is not equal to 2 divided by 5. Hence we can say division is not commutative. Hence in general, if A and B are two numbers and A plus B is equal to B plus A, then addition is commutative. If A into B is equal to B into A, then multiplication is commutative. If A minus B is equal to B minus A, then subtraction is commutative. And if A divided by B is equal to B divided by A, then we can say that division is commutative. Now let us check the commutative property for rational numbers. Let us start with addition. We take two rational numbers minus 2 by 3 and 5 by 7 and find minus 2 by 3 plus 5 by 7 equal to 1 by 21 and 5 by 7 plus minus 2 by 3, which also comes out to be 1 by 21. Hence we can say addition is commutative for rational numbers. Let us now check commutative property of rational numbers for subtraction. Let us take two rational numbers, say 2 by 3 and 5 by 4, and subtract them. We get minus 7 by 12. Now let us find 5 by 4 minus 2 by 3. On solving, we will get answer as plus 7 by 12, which are not equal. So we can say subtraction is not commutative for rational numbers. Let us check the commutative property for multiplication of rational numbers. So let us take two rational numbers, say minus 7 by 3 and 6 by 5, and try to find the answer after changing their order. We get minus 42 by 15 in both the cases. That means the order in which we multiply two rational numbers doesn't matter, they give the same answer. Hence we can say that multiplication is commutative for rational numbers. Let us now check for division. Let us divide minus 5 by 4 with 3 by 7 and also perform 3 by 7 divided by minus 5 by 4. On solving the first part, we get minus 35 by 12. Let us solve the other part. We get 3 by 7 multiplied by 4 by minus 5. This gives us 12 by minus 35, or that is same as minus 12 by 35. Clearly, the answers are not equal, and hence we can say that division is not commutative for rational numbers. We can proceed in the same fashion as for rational numbers and check for the commutative property for whole numbers and integers. We can check for all the operations, addition, subtraction, multiplication and division, and we will find that addition is commutative for whole numbers and integers. Similarly, let us check for subtraction. We will find that subtraction is not commutative for whole numbers and it is not commutative for integers. multiplication is commutative for whole numbers as well as integers, and division is not commutative for whole numbers as well as for integers. Let us start with the associative property. To understand the property, let us take any three numbers, say 5, 7 and 9. Firstly, let us add 5 plus 7 and then add 9 to it. We get 12 plus 9, that is equal to 21. Now suppose, let us add 7 plus 9 first and then add 5 to it. We get 5 plus 16, that is also equal to 21. Since the order in which we add does not change our answer, hence we can say that addition is associative. Now let us check associativity of subtraction. Say we subtract 5 minus 7 and then subtract 9 from it. We get minus 2 minus 9, that is equal to minus 11. And now let us first subtract 7 minus 9 and then 5. We get 5 minus of minus 2, which is equal to 7. Clearly, the order in which we subtract these three numbers will change our answer. So we can say that subtraction is not associative. Now let us check for multiplication. Let us first multiply 5 with 7 and then multiply the answer with 9. We get 35 multiplied by 9, which is equal to 315. Now let us multiply 7 with 9 first and then multiply it with 5. We get 5 into 63, which is equal to 315. So we can say multiplication is associative. Now let us check for division. We find that to check the associativity of division, if we change the position of the brackets and solve, then we get two different answers. That means that division is not associative. It is important to notice here that the numbers that we have taken, 5, 7 and 9, are whole numbers, and we have checked the associativity for the whole numbers. Similarly, we can check the associative property for integers and rational numbers. So basically our associative property is saying that if A, B and C are three numbers, they can be either rational numbers or integers or whole numbers, and if A plus B plus C is equal to A added to B plus C, then we can say that addition is associative. Similarly, if is equal to, then subtraction is associative. Thirdly, if then we can say that multiplication is associative. And fourthly, then we can say that division is associative. Let us check associative property for rational numbers. Let us take any three rational numbers, say minus 2 by 3, 3 by 5, and let us take minus 5 by 6. All the three are rational numbers. So let us check the associativity of addition first. We must have minus 2 by 3 plus 3 by 5 plus minus 5 by 6. Let us add. We get minus 1 by 15 plus minus 5 by 6. Let us solve further. We get LCM 30, and on solving the numerator we get minus 27. Now let us change the position of the bracket and add the three numbers again. This will give us minus 2 by 3 plus minus 7 by 30, and solving further, again 30 will be the LCM and numerator will be minus 27. So clearly we can see that both are equal, hence addition is associative for rational numbers. Similarly, when we will perform subtraction between these three numbers, we will find that will not be equal to hence we will say that subtraction is not associative for rational numbers. Let us check the associativity for multiplication of rational numbers. We find that on changing the position of the bracket in the multiplication will give the same answer, plus 30 by 90. So we can say multiplication is associative for rational numbers. Now it remains to check division is associative or not. So let us find the value of this expression. This will give us minus 10 by 9 divided by minus 5 by 6, which is equal to 4 by 3. Also we have to find by changing the position of the bracket, we get minus 2 by 3 divided by 18 by minus 25, On solving, this will give us 25 by 27. Hence, since the values are not equal, we can say division is not associative for rational numbers. Now we are in a position to make a table and show that addition is associative for whole numbers, integers, and rational numbers. Subtraction is not associative for whole numbers, for integers, and for rational numbers. Multiplication is associative for whole numbers, integers, and rational numbers. And division is not associative for whole numbers, integers, and rational numbers.